Assalamu alaikum guys, welcome back to our numerical computing series. Today I'm gonna explain you Gauss Jacobi method with another question. So let's get started. So guys, let's suppose we have been given three equations, that is x plus y plus z is equals to 3, 2x minus y minus z is equals to 3, and x minus y plus z is equals to 9. So, as I told you in the last video that first we have to check that if the given equations are diagonally dominant or not. So, we can see that in the second equation we have 2x, whereas in the first equation we have single x. So, to make first equation diagonally dominant, what we will do, we will rearrange the equations. That is 2x minus y minus z is equals to 3. Now this will become our equation number 1, and x plus y plus z is equals to 3. This will now become our equation number 2, and equation number 3 can remain same. Now to check if our three of the equations are diagonally dominant or not. As I told you in the last video that to check if the equations are diagonally dominant or not, what we do is we check that if are this element, this element, and this element, the coefficients are greater than or equal to the sum of the other two elements. For example, from equation 1 we have 2, the coefficient of x, and we have to check if it is greater or equal to minus 1 minus 1 minus 1 minus 1, that is minus minus 1. So 2 is greater or equals to 2. So this is correct. Now we will check for equation number 2. So we have to check now the coefficient of y is 1. So 1 is greater or equal to 1 plus 1, that is 1 is greater or equal to 2, and this is not correct. Similarly, for equation number 3 we have to check for z. So 1 is greater or equal to 1 minus 1, that is 1 is greater or equal to 0. This is all true, but we can see that we don't have equation diagonally dominant because equation number 2 is not dominant. So in this case we can conclude that we will not get the answer very precisely, but we can also solve this equation like we do when we have diagonally dominant equations. So we can solve this equation. Now we will make the matrix where we will write all the coefficients and the constants. So first we have 2 minus 1 minus 1, we have 1 1 1, now we have minus 1 minus 1 1, and here we will write all the constants, that is 3 3 and 9. Now we will make equations for x, y, and z. So for x we have x is equals to, we have 3 here, so 3 minus, as we have minus 1 minus 1, so minus, this will change into positive, plus y plus z, and as we have coefficient 2x here, so 2 will get in the divised, and this will now become our equation number 4. Similarly we will do for y. Now the equation for y will become 3 minus x and minus z. This will now become our equation number 5, and for z our equation will become 9 minus x plus y. This will be our equation number 6. Now to find the value of x, y and z, I told you earlier that for the first time when we are solving for our x, y and z, in first case we will put y and z is equals to 0 in all the three equations. So this will now become x is equals to 3 plus 0 plus 0 whole divided by 2, that is 3 upon 2. So x will become now 1.5. Now for y, we will put x and z is equals to 0. So 3 minus 0 minus 0, that is y is equals to 3. And similarly for z, z is equals to 9 minus, now we will put x and y is equals to 0, minus 0 plus 0, that is z is equals to 9. Now we can make table for iterations. Iteration x, y and z. So I told you earlier that in our first iteration we put all the values 0, and in our second iteration we will put the values that we found just now. So as you know that our x is equals to 1.5, y is equals to 3 and z is equals to 9. So we will input the values in our table in second iteration, that is 1.5, 3 and 9. Now for third iteration we will solve for x, y and z again, that is x is equals to 3 plus, now we have value of, now we will input value of y and z, that is 3 plus y, that is 3, and plus z, that is 9 whole divided by 2. So this will now become is equals to 9 plus 3 12 plus 3 15, 15 upon 2. So x will become now 7.5. Similarly for y and z we will put values of x, y and z. So as we have equation y is equals to 3 minus x, that is 1.5, minus z, that is 9. So our y will become now negative 7.5. And now for z we have equation 9 minus x, that is 1.5, plus y, that is 3. So z will become now 10.5. We will input these values of x, y, z in our table in third iteration. So x is now 7.5, y is negative 7.5 and z is 10.5. So by this method we can solve this equation if we don't have dominant equations. We will not get precise answer, but still we can solve this. So I hope you understand the concept of Gauss-Jacobi method even if the equations are not diagonally dominant. So if you want to learn more methods of numerical computing, do follow our channel and stay tuned.